Hello friends, welcome to Engineering Funda family. This is my second video based on Internet of Things video lecture series. In this video, I'll be discussing about components of IoT. There are 5 major components which is there with IoT. In this video, I'll be discussing about all components in great details. So let us see first how working is there with IoT system. So here, to understand working, you need to understand how components are structured. So first major component of IoT is sensors and actuators. See, sensors are used to capture physical input. Like as if you want to capture temperature, then you will be using temperature sensor. If you want to measure weight, then you will be using load sensor. If you want to capture leakage of gas, then you will be using gas sensor. Likewise, to capture any physical entity, you need to use sensors. Actuators are used to give physical output. Like we can use LED as actuator that will indicate whether things are happening or as if it is off, right? Likewise, you can use motor as an actuator. You can turn on the motor based on the requirement. So basically, actuators are used to give physical output. You should know in IoT system, you will be having real-time applications. So here, sensors are used to detect real-time data and actuators are used to give real-time response. Now I'll be discussing about second component, that is connectivity. See, basically we need to interface these sensors and actuator with IoT ecosystem. And to interface that, you need to have connectivity. That connectivity can be wired or wireless. Based on that, there are varieties of protocols available. Like you can have Wi-Fi, Bluetooth, Zigbee, cellular protocols like 2G, 3G, 4G and 5G. See, this connectivity component connects sensors and actuator to IoT cloud. But obviously, third component will be IoT cloud. See, in IoT cloud, we will be storing data and we will be processing on those data, right? Like we will be taking data from sensor via connectivity, and on that data, we'll be doing some process, and based on process, we'll be giving response, right? And that response will be given to actuator, and actuator will be acting on it. In detail, we'll be observing how IoT cloud is there. But remember one thing, IoT cloud is not compulsory block in IoT ecosystem, right? Fourth IoT component is IoT analytics and data management. Here, we perform data structuring for given application. See, IoT analytics and data management, that is very wide branch of engineering where algorithms are there, where deep learning is there, where machine learning is there. Many things are there with IoT analytics, right? Where our agenda is to provide meaningful insight to given application. And to provide that, we need to act on the data, right? In detail, we will be observing that in this video itself. So fourth block, that is IoT analytics and data management. Fifth block is user interface, right? So at last, user will be using application. So user can monitor the application, and user interaction with application, that is defined in user interface. Like as if you have one IoT application where you are observing your home, right, by staying over here in India, and your home is there somewhere in Canada. Then how that user interaction is there with the application, that is defined in this fifth block, right? That is how 5 blocks are there. Now what I'll do is I'll be explaining you all 5 blocks in great detail. So let us see first how sensors and actuators are there. To understand sensors, let me give you some examples of sensors over here. We can have touch sensor to identify the touch. We can have temperature sensor for a measurement of temperature. We can have flow sensor to understand flow of fluid or flow of gas. We can have position sensor to identify the location. We can have load sensor for a measurement of weight. We can have gas sensor for identification of leakage of gas. We can have speed sensor to identify the speed. And we can have sound sensor to identify sound, right? So that is how we are having varieties of sensors to measure physical entity. Now, first I'll be discussing about basic definition of sensor. So here, if you talk about basic definition, then you should know sensors are used to measure physical input from the surrounding. and it converts it into electrical signal. That electrical signal may be analog or digital. Based on that, you can say whether given sensor is analog or digital, right? Here, when we talk about sensors, then those sensors are integrated in embedded system, where with embedded system, we may have microcontroller or microprocessors, right? One example is given, like you are using smartphones. So in smartphones, there are many sensors. I have listed few names over here, like GPS sensor, fingerprint sensor, tilt sensor, we are having camera. Likewise, there are so many sensors available in smartphones. We can have some IoT applications even in which there can be few sensors even. But in smartphones, there are so many sensors available, right? See, size of sensors is getting very compact due to advancements in technology, right? So here, when you select sensors, at that time you need to see what is the accuracy of sensor, what is the precision of sensor, what is the level of intelligence, and what is the need of application, right? Based on that, we should be selecting sensors. So that is how basically sensors are there. Now I'm going to discuss about actuators. So actuators are based on how we provide physical output. Few examples are listed over here, like we can have motor, we can have valve, we can have pump, we can have LED, we can have speaker. So these are the actuators where we provide physical output, right? Here, see, sensors are used to sense the physical entity and actuators are used to act on it. Here, cause of action and to control the situations, we are using actuators, right? To make something happen based on the trigger, actuators are used. Control signal could be analog or digital. See, based on analog and digital actuators, we are providing control signals, right? Here, to turn on or off something, we are using actuators. Like you can use LED to turn on or turn off something, right? So that is how actuators are there. Now let us discuss second IoT component, that is connectivity. This connectivity and gateway is second component of IoT ecosystem. Connectivity and gateway protocols make sure there is a smooth interconnection in between sensors and actuator with IoT cloud. You need to understand few essential rules of connectivity and gateway. Let me discuss about those essential rules of connectivity protocols. See, it plays crucial role in connecting sensors and actuator with IoT ecosystem. See, based on medium and range, various protocols are available. Like we can have cellular protocol, Bluetooth protocol, Wi-Fi protocol, and LoRaWAN protocol. Let me discuss about those protocols in terms of range, so that will give you more clarity about how those protocols are used. See, when we talk about IoT protocols for connectivity, then for less than 300 feet, we can use Bluetooth, Zigbee, NFC, and Wi-Fi. If range of connectivity that is there below 5 km, then we can go for cellular communication protocols where we have 2G, 3G, 5G protocols. And for lower than 100 kilometers, data will be there on internet cloud where we have protocols like LoRaWAN, Sigfox, and NB-IoT. So likewise, based on range also, varieties of protocols are available. Now, let me discuss about how we have IoT gateways. So IoT gateways that provides interconnection of edge devices to IoT cloud, right? So here we have IoT cloud. Here we are having edge devices and IoT gateways that will provide smooth interconnection of these devices without IoT cloud, right? So IoT gateways that gives connection in between edge devices and IoT cloud, right? Let me discuss about essential roles of IoT gateway. So it ensures seamless communication in between edge devices and IoT cloud. It provides easy management of data traffic. Here, it offers security as well. It will be protecting from malicious activities, right? So there is a need of security that can be provided by gateway. It will be having latest encryption practices by which it offers smooth security over here. It also provides data processing in between edge devices and IoT cloud, right? See, it will be minimizing large data size. The reason is when you interface sensors with IoT cloud, at that time sensors will be detecting data continuously in real time, right? So there will be large data. But to IoT cloud, if meaningful data are forwarded, then there will be smooth practice in terms of data size, right? So here IoT gateway that also provides minimization of large data. And here we have intelligent IoT gateways which does those tasks, right? So that is how roles are there with IoT gateway. Now I'm going to explain you third IoT component, that is IoT cloud. IoT cloud plays essential role in IoT ecosystem. It is not compulsory component of IoT system, but still in some system we use it where we do data processing. Let me discuss about essential key roles of IoT cloud. See, data needs to be processed, and that is what the case which we do it at IoT cloud. And based on processed data, we provide make or break deal, and based on processed data only, those decisions are taken, right? So unnecessary decisions are filtered out over here, and that is what the case which we perform over here at IoT cloud. See, latency cannot be compromised over here, right? If you are talking about real-time applications, then latencies are not allowed, and to have real-time output, IoT cloud that plays very essential key role in IoT system. When we talk about IoT cloud, then you can say it is the brain of IoT ecosystem, and this cloud is optional, it is not compulsory, right? Here, see, with the use of edge computing, we can have local processing, right? So for local processing, we are using IoT cloud, where with the use of edge computing, we can have local processing. Like for some group of nodes, we are providing that processing, right? As I have told you, this IoT cloud is optional, but if you talk about large ecosystem, then at larger level, it is a bit difficult to give real-time output. So for some selected region, we can provide IoT cloud where selected region is having some selective decision. And that is what the meaning which is there with local processing, right? So that is how IoT cloud that functions in IoT ecosystem. Let us have fourth IoT component block. Fourth major component of IoT system is IoT analytics and data management. Let me discuss about key essential points of IoT analytics and data management. So here, first task is data extraction, second is data analytics, third is data aggregation, and fourth is data classifications. So these are the four tasks that we perform at IoT analytics and data management. Here, see, data is the fuel for IoT applications. So basically we are acting on the data, right? So data is the fuel over here, and based on data only, we are performing applications. So here data is the fuel. We are converting raw data into useful insights over here. So we are having raw data, random data that we are capturing from the sensors, right? But from that raw data, what is the meaningful insights that we need to decide over here? And that decision that we take it over here at data analytics and data management, right? See, data extraction, data aggregation, data classifications are major tasks of IoT analytics and data management. Deep learning, that we use it to predict data for some applications. So in some applications, we may need to have deep learning by which we will be predicting data, right? So data prediction is also key role over here in IoT analytics. See, storage power and intelligent computation are the key parameters of IoT analytics and data management. So here we need to identify first how much storage capacity is there with our cloud, and in that how much intelligent computation that we do. Based on that only our application will function, right? So these are the key parameters which is there with fourth block, that is IoT analytics and data management. Now I'm going to explain you fifth block of IoT ecosystem, that is user interface. This fifth component of IoT is user interface, by which user will be interacting with IoT application. So user interface is very essential. See, to have user interface, you need to understand some key parameters like what is notification in application, how alerts are provided in application, how do we have remote control to the application, and how user can observe live trends of application, right? See, if user wants to monitor the task and as if user wants to control the task on field, then interface of user with application is very essential, right? And for that, there can be varieties of notification, like normal notification that we all know, like if some application is giving you some notification on your device, so that is normal app notification. But notification can also be provided with the use of emails. It can be also provided with the use of alerts and alarms, right? Here, it can also send back the command to the field devices. Like you can also send back the commands to the field devices, right? By giving command directly, you can control the application. So manual control is also provided over here. Automatic control is there, but manual control that can be given by user with the use of application. Here, user can also observe actual live feed and it can also see the trends, right? So how exactly data is there in terms of graph, that can be also viewed by the user, and based on that, user can take some manual decision as well. Automation can be done over here, but manual decision also can be done over here, right? So that depends on how user interface is there. So these are the 5 essential components which is there with IoT ecosystem. I hope you have understood all those things. Still, if anything that you would like to share, please note it down in comment section. I'll be happy to help you. Thank you so much for watching this video.